Hi everyone! My research investigated the disproportionate effects of climate change and focused on changes in mortality, fertility, and sex ratios at the population level. In the context of this study, population refers to a subset of individuals of one species that occupies a particular geographic area. I conducted this research with the goal of better understanding how local populations are affected differently by global warming, the importance of this data, and what actions scientists are taking to mitigate these effects by compiling and synthesizing pre-existing primary and secondary data. This research also serves as a literature review on the topic. This research investigated the consequences of climate change at the local level, but I want to take a moment to talk about global climate change first. I do want to note that climate change includes several variables, but I'll be focusing primarily on temperature changes and global warming here. We know the planet is warming at an unprecedented rate, and on average, global temperatures continue to rise well above the mean each year. Global warming is primarily driven by human activities releasing greenhouse gases. Current models predict the average global temperature rise an additional 4 degrees Celsius, shown here in orange. And in the best case scenario, if we make an effort to greatly reduce CO2 emissions, it will still rise at least 1 degree Celsius during the 21st century, shown here in purple. By zooming in to look at how global warming is affecting specific regions, we see that areas near the Arctic and at high latitudes are warming much faster than areas near the equator. The Arctic is warming twice as fast as the global average, and projections show this trend will continue. Because climate change is occurring so quickly, many species are experiencing local extinctions. One study found that local extinctions occurred in 47% of the 976 studied species categorized here, and this number will continue to rise with increasing temperatures. Before populations experience local extinctions, they start to experience changes at the population level, including rising mortality, declining fertility, and shifting sex ratios. However, human intervention through conservation and technology can help mitigate some of these changes. I'll talk about rising mortality rates first. Within populations, mortality rates are rising for species that are sensitive to changes in temperatures, like pikas shown here. Normally, pikas rely on insulation from heavy winter snowpacks to keep their dens warm. However, due to global warming, there has been less snowfall, leaving pikas exposed to cold temperatures, resulting in mortality. The current pika population in the Rocky Mountain National Park is shown here, and by 2099, you can see the projected population is almost completely gone. Corals are also indirectly impacted by global warming, as heat waves are causing mass bleaching events. As shown here, moderate and severe bleaching events are becoming more frequent. This is occurring in large part because the global ocean temperature has risen by more than 1.3 degrees Fahrenheit since the late 19th century. Although some coral reefs have recovered from coral bleaching events, the majority of coral have not, and bleaching ultimately leads to mortality. Climate change is also driving population declines by affecting fertility and reproductive success. Fertility rate, sperm count, gamete number and viability, fertilization success, and sperm form, function, and concentration can all be affected by rising temperatures. One example of an affected species is bees. Here we see declining fertility in the form of reduced sperm viability in queen bees exposed to abnormally high temperatures. In addition to counting the total number of individuals lost or added to a population, the number of females versus males, referred to as sex ratio, is also a useful metric for animals that use temperature-dependent sex determination, or TSD. In TSD species, the gender of the offspring depends on the temperature their eggs are exposed to. Reptiles and amphibians like turtles and alligators and some fish are vulnerable to temperature changes as TSD species. For the three groups shown here, you can see how the number of males changes based on the temperature eggs are hatched at. One of the most studied TSD species is turtles. In this case, lower temperatures result in all male clutches, and higher temperatures above 31 degrees C lead to all female clutches. As temperatures rise, the population is shifting to having more females than males, as shown here, and this imbalance is projected to increase. In some areas, turtle populations are already reaching 95% female, resulting in serious concerns about maintaining enough males to fertilize eggs. Having data on population changes is essential to effectively focus conservation efforts on these populations that are most at risk. Unfortunately, there are limited resources to help threatened species, making knowing which local populations are most affected of the utmost importance. For example, knowing which pika populations are experiencing the highest mortality rates directs important conservation efforts to the areas most impacted by global warming. For pikas in particular, monitoring local populations is crucial because, unlike most species, it's the pika's geography, not their genetics, that have the biggest impact in predicting their response to climate change. Groups like the Colorado Pika Project are actively working to save the species, so understanding which populations are most at risk is important to their mission. Another approach is to use innovative technology to restore populations that are suffering from rising mortality rates. For example, in areas with high coral mortality, 3D printed coral can aid coral restoration efforts. For example, Archie Reef 3D prints tiles that provide a foundation for coral to grow on. Initial tests in Hong Kong show great promise, and in the first 6 months of observation, 4 times more coral survived on the 3D printed tiles compared to conventional artificial reefs. So we know that changes at the population level are occurring in several species, which serve as red flags that signal conservation biologists to intervene before local extinction occurs. However, soon many of these population changes will become irreversible. More local extinctions will occur, and species will not only be lost from one area, but globally, leading to permanent biodiversity loss. While humans should care about these species for many reasons, for those who don't value biodiversity, the reality is that these population level changes are not just affecting wild animals, but affecting humans as well. An estimated 37% of heat-related mortality is attributable to human-induced climate change, and heat-related mortality events are predicted to increase. Furthermore, natural disasters become more severe and more frequent due to climate change increasing the frequency of mass mortality events. Regardless, many nations continue to burn huge amounts of CO2, with China, the US, the EU, and India being responsible for just over half of the global greenhouse gas output. In the short term, conservation efforts focused on at-risk populations may help combat increasing mortality, decreasing fertility, and shifts in sex ratios. But in the long term, humans must slow global warming by limiting further greenhouse gas emissions, by investing in green energy, incentivizing sustainable practices, and continuing to collect data on population changes and prioritizing effective conservation. In order to save species, including ourselves, the underlying problem of accelerated climate change must be addressed by world leaders, industries, and individuals. We must all work to take action. Thank you.